Welcome back. We are going to continue with week 3 of surveys and site plans. Whenever we're doing surveys, we need to have a common reference point. Remember what I said in the first presentation about speaking the same language. So we need to understand something called a survey datum. Basically, a datum is a coordinate system and reference points that allow us to locate any spot on the Earth. If it's horizontal, we use it to collect positions on the surface of the Earth, such as corners of a property. And we're basically measuring distances and angles. A vertical datum has a base that is a zero elevation, and we reference various heights of points against that zero elevation. So we're simply measuring height distance differences. But all of these datums have one thing in common, and that is to work we need to know how big the Earth is. And believe it or not, prior to the 18th century, there was no reliable scientific estimate of the size. So the first estimate that was reliable was published in 1743, and since that time a number of others were published, including one by a British scientist by the name of Clark in 1866. That's important because the U.S. system is based on Clark's work. And for horizontal datums, that is, again, angles and distances, locations of points on the Earth, Clark translated into the NAD 27, or the North American Datum of 1927, and it was centered about a point near Tipton, Kansas called Meade's Ranch, considered at the time to be the geographic center of the continental United States. It was replaced by the North American Datum of 1983, which was based more on satellite observations. But this datum would be known as lat-longs for latitudes and longitudes, or coordinates. So anytime you see those words being used, we're talking horizontal surveys. Vertical datums began with the National Geodetic Vertical Datum of 1929, and that was based on mean sea level that was measured from 26 gauges that measured where the tide was. There were 21 in the United States, 5 in Canada. That was superseded by the North American Vertical Datum of 1988. Sometimes you might find local datums, none of which are associated with NAD 27 or 83 or NGVD, NAVD 29 or 88. For example, there are the Mercator projections, which were developed by a Flemish cartographer back in 1569, and it became the standard map projection for nautical purposes because of its ability to represent lines of a constant course. Sometimes you may find a really local datum, such as Lake Erie. If you go out to the Canal Visitors Center for the Ohio and Erie Canal out in Valley View, you will find this particular diagram, which shows the elevations of the canal, and they're all referenced off of Lake Erie with an elevation of 94 feet. Well, we know that above mean sea level, Lake Erie is about another 500 feet higher. So if you were to look at maps, remember that map I showed you of the Cuyahoga Valley Railroad from 1919, they are based on these elevations. And so the purpose of discussing this is that we're not going to work with doing surveys or adjusting datums. But I want you to be aware that you need to know that different datums exist, and which one is being used on the project that you may be working on. Because if you take a set of old plans, you need to know what they were referencing if you're going to work on them. If you take surveying courses, you'll get more advanced training in these areas. There is also the National Geodetic Survey. If you go to this website, and I will see that it gets posted on Blackboard, and click on Survey Mark Data Sheets, click on Data Sheets, click on Rectangular Search, you will be able to get data sheets of all survey markers in an area less than or equal to 2 by 2 degrees. So anything larger, you'll get an error message, okay, and then you will get all the stations that may have actual surveyed benchmarks. So you have to enter the min-max. So we have the minimum latitude, that is the distance from the equator, of 41 degrees 30 minutes to 41 degrees 37 minutes and 30 seconds, and longitude minimum of 098 30 00 098 37 30, and we'll get a list of all different markers that have already been surveyed. This is the data sheet you will get for something called Medport. It is out on the Medina Municipal Airport along Route 17. It tells you that this is the coordinates, remember that term, coordinates, based on NAD 83. This is the elevation of the airport based on NAVD 88. So again, it tells you what datum you are using. And you will find markers like this set in a concrete pedestal, relatively unmovable, and this point here will be those coordinates that have been measured and that elevation. So when do we have to do surveying? Well, we have to do it before design. As we remember from part 1, we need to know what the layout of the land is, how it rises and falls. Do I have to level it? I need to know it before construction because I have to know what those points are and where I'm going to have to be cutting and what I'm going to measure from. We have to do it during construction because the survey points that we put in before construction may have been moved, or we need to make additional measurements during construction. And then we have to do it after construction to see if the project has conformed to the plans. For example, my favorite example of the apron at Akron-Canton Airport for the National Guard, we had to go out and survey this during construction and after construction to determine what the actual quantities of work that were performed were. So let's take a look at some site plans. You'll be using the drawings that are in your text as well as the branch bank that is available in handouts. So let's recap. Plot plans. Okay, they are going to show, they might be called plot plans, they might be called site plans. The size, the shape, and the location of the site, the building on the lot, its relation to other buildings and objects. This is a site plan. This is the Akron-Canton Regional Airport. Here's my apron up here, and you can see its relation to other parts of the airport and to the general community in which it sits. So let's take a look at brick veneer number 4. Now, there's a lot of use of what I call white space, extra space on the drawing that the designer took advantage of. That's perfectly okay. It's my preference and my recommendation, if you're ever in the process of designing a project, if this is the plot plan, only plot plan information should reside on this drawing. We have here bathroom elevations, light fixture schedules, and door schedules. Another reason why Rule 3 exists, to take it all together. If you were handed the plot plan and you wanted to know the light fixture schedule or the door schedule, you wouldn't think to look on this drawing. That's why you need to look at them all at the same time. So let's take a look at the actual plot plan. Notice it is drawn to a scale of 1 inch equals 20 feet. This is measured at 70 feet. So if you had a simple carpenter's rule, this would only be 3.5 inches long. Notice the north arrow. The north arrow does not point up. Now, it shows me the property lines and their dimensions, but it doesn't show me the bearings, the direction that they are going. If you had to lay this out in the field, you would be missing data. Notice the lot line here doesn't have a dimension, but it does show the general shape of the building. It shows the location of this corner as 70 feet from this property line, but it doesn't fix the corner from any of the other property lines. So you don't know how far back this may be from the existing road. Notice the drive is not in the contract, but we have a lamppost that is 5 feet from this driveway and 60 feet from the house. Until you know where this driveway is going to be, you can't fix this lamppost. So that means you need to coordinate with whoever is putting in the driveway. There's also the septic tank and a tile field. So there are some underground utilities being shown on this plan. Once again, here's a close-up of that 70-foot mark and the lamppost and the drive in the contract. Now, this is where you need to turn to handouts and branch bank sheet A1. And here we call it, it's called a site plan. Once again, we have a site plan here and a foundation plan here. You can see the size drawn here. This is scale of 1/4 inch equals 1 foot. Here a scale of 1 inch equals 20 feet. 2 sheets might have given you a little more detail here. So let's take a look at it. Once again, my north arrow is not pointing up. This is pointing now to the left. Scale of 1 inch equals 20 feet. So we would use an engineer's scale to get rough estimates of these dimensions. This is a dimension of 151.78 feet. I would rely upon the written dimension rather than trying to scale it off. So let's take a look at some close-ups. We have direction, bearings. We have distances. So if I can find the point of beginning, which is not clear on this drawing, I can lay out these property lines. Notice that the plan also shows some other features such as curbing, asphalt, striping. But these are just in general, there is no detail. Now we turn to Wendy's sheet C3, and it's called a grading plan. Now we're getting into some earthwork, some pushing around of soil. And as we look a little closer, we'll see that it is a relatively flat site. Remember that a dashed line will represent existing contours. These light numbers, the little x, represents existing elevations. Notice 774.09, 773.91. So here's a line running through here which suggests to me that this is elevation 774. The dark or bold numbers, as well as the solid and dark lines, indicate proposed elevations. Notice here's my 774 existing elevation, and it picks up from here and we find 774, then 775, 776, and 777, and the top of the berm is 777.50. And then 76 comes down, so you can see this is going up and coming down. These dimensions here, 774.75, 774.5, are proposed, not existing. Once again, a closer view of it. We do have some underground utilities. STM is more than likely storm, and you can see the direction of flow, an elevation of the rim of the inlet. Here is the bottom half of that same detail, and you can see that the storm lines all converge and flow out to an existing storm sewer. You can see again, dashed line, light printing indicates an existing sanitary line. Here is an existing storm, and the new storm will connect to it. So that's a good segue into underground utilities, and that ends part 2 of week 3 and ends the week 3 presentations. We will continue with underground utilities next week on week 4.